Welcome to the second part on arrays. And in this part, we are discussing the remaining topics of this chapter. This is chapter number 6 from the book Detail and Detail. And in the last part that we discussed about the arrays, how arrays are declared, how arrays can be declared using their indexes or indices over there. We talked about how they can store. We talked about the word constants as well, how it is going to be passed by reference or passed by value. This constant is actually going to make it or protect the array, so it's not going to allow a change inside that array because you are passing the whole array as a parameter. We also talked about that how you're actually going to store strings or characters over there, and this is actually going to talk a lot about of the so we talked about how characters and strings are actually being printed, how they are done. We talked also about the null terminator, and we also had some few examples also done related to histogram, bar chart, and how you're going to find out the maximum, minimum, or you're going to talk about the summing of some elements inside an array, or if you want to take out the mean. Do kindly check out the examples or the end problems at the end of this chapter. They are very much important. And remember, coding has to be practiced. Otherwise, you are not going to get the essence of programming and you're not going to. Because just going through slides and having this data coming up is not going to help you. And this is not going to be beneficial. So you have to go through the there. Now, this topic which we have to start and here is actually called as the bubble sort. And I told you a little in the last lecture also that what type of this is going to do. This is actually called as a bubble sort, and bubble sort here means that you are going to take two elements inside an array, or array is not just important because since we are talking about the arrays chapter over there, because bubble sort can happen for a linked list also, for any kind of a row, column or something like that, and you can apply this bubble sort algorithm. These are actually algorithms which are applied on data structures. So supposingly if you have a data in form of an array in this case, so you are actually going to make it work something like this. If you see over there, this is comparing the adjacent pair of elements, and if they are in the wrong order, swap them. Of course, the one which is at the lowest index or index over there, the subscript over there, you're going to move it there, and then you are going to swap them, and you're going to repeat it until the array is sorted. So larger values bubble to the end. That's why the point of using or calling it as the bubble sort is this, that the larger values or the bubbles, they reach towards the end of the array. So if you have an array over here, this is actually a four length array, you can see over there. So the position at 0 you have 5, then at position number 1 or index 1 you have 2, then you have at position number 2 you have 8, and then at position number 3 it is 1. So this is relatively not sorted. So you can see 5 is there, so practically 1 should be there. So the algorithm is something like this, that first of all you're going to take these two, compare these two. If they are in order, by order here means that 5 is going to be here and 2 is here, because 2 is at the lower as the higher. So this is not sorted. So what you are going to do, you are going to swap these two, and of course this swapping has to be done by a temporary variable. I will just show you the code as well, and I will show you it running as well, how this is going to work on. So you have an array here, this 5 and 2. So first of all, it will swap 5 and 2. When it will be swapping, the array will now become 2581. So what you have done over there, the first swapping has been done for the first two elements over there, which are at 0 and 1 position. So you've done it. Now, when you again analyze it 2581, and now this time you analyze the second and third position, okay, which is actually in case in form of indexes, it is actually point number 1 and point number 2. So when you compare it, they are exactly in the order because 5 is smaller, 8 is larger, so it's totally okay. Then if you see it over there, there is no swap. Then you go, if you go on and next see the next two, which is 8 and 1 over there. Now this 8 and 1, 1 is going to be swapped, 8 is going to go there. So when this is going to be done, the final answer would be 2518. Now this is still not done. So you're going to repeat this again and again till there is no swapping to be done. For example, after this 2518, you will again start the process by 2 and 5, and that 2 and 5 means they are still ordered, no issues with that. So this will go on for 2518 over there. Then The next thing is 5 and 1. So 5 and 1 will be taken. Now this needs swapping. So you have to swap it. Again, remember this swapping has to be done by a temporary variable. And I will show you that temporary variable. The implementer is also there. I will show you this one on the Visual Studio. So when this swapping is done, so now number will be 2158. Now here you will do the again 5 and 8. Okay, 5 and 8 are totally okay, no problem with that. So again you will start the swapping from the start. So this will be 2 and 1. Now here swapping of 2 and 1 will be done, and now the answer will be 1258. Now this is sorted, but still, just to confirm that now it is sorted, you will again pass it through that 2 and 5. Yes, it's okay. 5 and 8, okay. So this means that this bubble sort algorithm will remain up till a point when there is no swapping to be done. So automatically the algorithm will find it out that okay, there is no change required over there inside any two adjacent pair of elements. Now, how this is being implemented? Over here, I have just shown a function. I will show you its implementation also, how you're going to call this one. The function is there, it's void. So it's actually going to take the array, change its sequencing, which means change its position of the elements inside the array, and it's also going to take in the size. Of course, size is something very important because how many times you have to do that pass, that's actually dependent upon it. So here if you have like supposedly four elements, so you can have like four times pass over there. So this times, which means inside this for loop, this loop is going to run from 1 till the size, and the size over here supposedly in our case over here this is 4, so this means this will be 4, so 1 2 and 3 this will be running. So the pass means that there will be four passes, actually in fact 1 2 and 3, three passes over there. So three times this outer loop is going to run specifically for this array, because this is going to be passed on inside this one. At present there is only the function written over there. Then inside the inner loop the comparison is going to be done. Now inside this inner loop you are going to start from 0 because the index starts from 0, and I is less than size minus 1. And what is size? Size over here is the size of your array. So here in our case, let's say if I'm using this same array, so this is 4, so 4 minus 1 is 3. So this inner loop will run for 3 times. Okay, so 3 times or 4 times. So this will be starting from 0, it will go to 1, it will go to 2, and this will run 3 times, because here 4 minus 1, the answer is 3. So this will run 3 times over there. This one is running 3 times, this one is running 3 times over there. Now how you're going to do that? Inside this inner for loop, you are going to compare one element of ai with ai plus 1. Now since a array is already there inside the loop, so you just need to put in the value. So what will happen? I will be equal to 0, so 0 will be compared to 1. So what will happen? The first thing, 0 and 1 will be compared. Now if this is not okay, which means if this greater sign is not there, actually it's there, then you have to swap them, the same condition. So 5 is greater than 2, so this one would be true, then you have to go inside this if else statement and you have to swap them. So there is an in temporary variable, and I'm going to store that value which is in ai inside temporary, and wherever there is ai, I am going to take the value of ai plus 1 and swap it. So these three statements are just swapping the value over there. Now this loop will again start. At present was 0, so that was 0 and 1. Now it will start for 1. So when it will be I is equal to 1, so here it will be 1 and here it will be 2. So it will be 1 and 2. So 1 and compare will be 2 will be done. So now this time 2 and 8 will be compared over there. After swapping, the answer is 5 and 8. So this time now 5 and 8 will be compared. These are true. There is nothing greater over there. So there is no swapping required. So no if else statement will work. Well and good, no problem. Then this inner loop will again go. Again, this time it will be 2. So 2 and 3 will be now compared. What is 2? 2 is this, 3 is this. So here, when it is over here, this will be 2 and 3. So now this requires swapping. So this will be 2518. So you can see over there, this pass number 1 is actually the first value of this outer loop, where pass was equal to 1. So this is going to run for 3 times. Why 3 times? Because it has 4 over there, the length is 4 over there. So this is going to have starting from 1, then 2, then 3. So this will be 3 passes over there because you have four elements. Of course, whenever you are going to have a pass, you are going to swap to any two values. So that's why this is going to be three times running. This is also going to run three times. So practically, this if else statement is going to run nine times. And when this is done, the end result would be that your array A is actually going to be sorted. Now, the implementation of this. Let's see that implementation. I have that implementation, I guess, over here. If I'm not wrong, I guess I have it. Yes, this is the bubble sort. Now, over here, what you are seeing over there, this is the bubble sort. Not actually, this is a little, not this one. Actually, this is bubble sort is, I guess, if I'm not wrong, bubble sort is somewhat here. This is sorting an array inside it, and bubble sort was somewhat here, I guess, if I'm not wrong. This is linear search, and this is binary search. This is actually median mode bubble sort. Actually, bubble sort is here. I don't want to actually go with this thing, and that's actually going to create a problem for you. That's why I'm making it into maybe this one. Where's my bubble sort? So bubble sort should be here. Actually, if I'm not missing it, most probably. Anyway, if I can't find it out, anyway, I can still show this thing, bubble sort over there, this algorithm. What is it taking? It is taking an integer array over there. This is a bubble sort. Let's see its implementation, how this is being done. The array is here. This is the array which is going to be supplied to whatever is the function. And you can see over there, whenever the bubble sort algorithm is being called over there, this is actually the median mode and all that something. The whole work is going to be done. And you are going to have the bubble sort over there. The bubble sort algorithm, which is exactly the same, just like we have just done, is exactly the same. You can see over there. Here, pass is again less than size. And what is size over here? Size is here is 99. Why 99? Because here the values inside this array is 99 values. Because you can see this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 and to 9, and then you have 9 over there. So this is 99 over there. So the bubble sort algorithm is exactly the very same over there. You can see this is the for loop, and from here to here, this is the for loop over there. The inner for loop is just going to run from j0 to whatever the size is. That size is 99, so it's going to have 98 is over here. So it's going to go from 0 to 97 over there, because whenever you have 97 over there, that j would be 97, and here it will be 98, and that will be the last element. So you're going to compare the second last element and the last element. So this is completely going to work over there. So this for loop and this for loop is going to work exactly like over there. Now if I just want to turn this on, let's say I want to turn this on inside my main loop. Let me just show you the, I guess if I can comment out these two, and I just write down bubble sort and over here, and this is the print array. So I'm just going to print an array, and print array is again also a function. I'm just going to tell you that what is that print array. Print array is just going to print that function. So you can see begin a new line after every 20 values. It's just giving out over there that if your number is going to be 20, then you are going to have backslash n printed. Otherwise, it's going to just print your printf and a over here. So when I run this one, let's see. And here you can see it's sorted. What was the previous one? Let's say if I want to find out the previous one also, let's say I want to call the before it. Let's say I call this one before it. So you can having a print array. What is response? Response is the array which I am passing. Response is an array. Remember, response is an array, and I'm printing it. So here I am printing it. So here I am printing it before bubble sort over here. And here I am printing it after the bubble sort. So now if I just do it again, so you can see now, I guess I can add a puts over there just to over here. I guess, yes, sorry. Okay. So just putting a line over there. So it's yes. So you have this is the main array which has 99, and then after sorting you can see this is 9999999 and 1 2. So everything is sorted. So this is a very simple, and this is a very, very crude way. This is bubble sort, but this is something very, very crude way of doing it. Why? Because whenever you are actually going to have a bubble sort algorithm, if you have like 99 entries, just like our case now, so it will be 99 here and 99 here. So 99 into 99 times, this is going to run a lot amount of time. It's going to take a lot amount of space. And supposedly if your array has something like 1000, so just imagine out 1000 multiplied by 1000, it's like approximately more than, I guess, 1 million. So you have 1 million times this loop will be running, and it's going to take us some time. So bubble sort implementation is not the best implementation if you want to sort out something. But yes, this is one of the algorithms in which you are going to pass on from one element to the other, or actually making two elements compare with each other, adjacent elements. If they are not in order, then swap them. If they are in order, then proceed to the next one. So this implementation is something very, very important. And remember, we always need a temporary variable for swapping. We have done this one before. Whenever you want to swap two variables, remember, everything remains the same. Just as this, that this time you're not having variables. Here you have arrays, and those arrays are integer arrays over there. Now, another algorithm which is called as linear search. So supposedly inside an array, you want to find out that what is the position where you have found that element. Supposedly this is an array 10, 25, 30, 45, 50, and you want to search 30 over there. So 30 is somewhere at 0, 1, 2, 2 over there. So how you are going to do that? Now, when you are going to do that implementation, it's again very simple over there. You can go through this thing very easily. I'm not going to go in detail over here. You can see integer, it's going to return something. It's going to return that number from at, or the position at which that array is there. Here you are using const over there because the array, you don't want to change it, because we don't want to sort or something. You just want to find out that where that array value is. Okay. Then second parameter is int key. Key is actually what you actually want to search. Okay. Key is actually what you want to search over there. Int size, that is the size of your array. Okay. Over here, int I equal to 0, I less than size. Of course, when you're going to search, you have to search it from 0 till the last position. And last position is size minus 1. So here this will automatically go to size minus 1, because this is not equal to go to size. Then plus plus I, again for loop implementation, nothing fancy. And you are going to compare it to the key. So if your array I is equal to key, then this means, okay, return I. Otherwise, this loop will continue to go on for like whatever the size. So supposedly if you have 99 values in your array, you are going to have 99 times this loop will be. If 99 loop is going on, supposedly the key is found out as something at 2 position. So this will straight away return it, and no need to fill the whole loop even, and then the function will be returned. And this function is being over here int position is a variable, is an integer over there, and it's going to store whatever this function is going to give you. So whatever that array has the 30 number at whatever position, so inside supposedly you have an array, and that array has all the marks of all the students whatever they have scored, and I want to supposedly find out, okay, who has 30 out of 30 supposedly, or who has 30 marks over there. So this will tell me, okay, at this position, this is the array that is having that value. So if position is not equal to -1, because -1 is going to be returned if nothing is found. This is also a chance that if there is nothing found, then this is -1. So if position is not equal to -1, equal to -1, so this means that this is found at index, whatever the position may be. It may be 0, it may be 1, it can be 2, it can be 3, else it is not found. So this is a very simple linear search. So here you are actually searching the array for a particular value, which is here again called as the key over there. Okay, the implementation, I guess, here also is in this example. You can go through this one. You can see over there is a constant int array int k size over there, and you can search whatever you want to do it. You can go through this example. These are the same examples available from the book examples. Then the next very important is, up till now your arrays have been one dimensional, which means they were increasing in one. So they were just rows over there. Now you are adding columns. So you are actually making it inside a matrix. Okay, I hope you are familiar with matrices because of your math background if you have any. So matrices are 2D arrays. So here you have been just using the data type, integer, character, or whatever you want to store it, array name, and then you had rows over there. So that rows was actually telling you, so you are having row equal to 5, so this was going from 0 to 4. Now here adding another rectangular bracket which is called as columns over there, and that actually changes the whole game. Now it is actually a matrix. So here this is the row number 0, column number 0, row number 0, column number 1, row number 0, column number 2, row number 0, column. So if you have put int grade 3 to 4, this means you have 3 rows and 4 columns. I'm again repeating int grade brackets 3 close bracket open again 4 over there. So this means this is 3 rows and 4 columns. Remember, rows comes first, columns comes in the second part. So here this is a, you can see over there, this is a 3 cross 4 matrix actually, which means 3 rows and 4 columns over there. So the total elements would be 3 into 4 into 12. Okay. And again, the indexing always has to start from zero. Remember, either it's rows or column, a single dimensional array or two-dimensional array, you always have to make it zero. So you have to start from 0 and 0. So this element is always going to be 0, 0. This element is always going to be -1, the size for each one, row and column both. So this one would be 2, this would be 3. Why? Because 3 is here and 4 is here. So 2 and 3 will be there. So this is a two-dimensional array. Now let's see an example of 2D arrays that will be much easier for you to understand. Now, 2D arrays over here, whenever you have at initializing a 2D array, the initialization has to be done using the curly brackets again. And that curly brackets over here, you can see you have integer matrix 2, 3 over there, and you have row 0 and row 1. So you are separate. Now you can put them in one line as well, but just for aesthetically, because you're the programmer, whenever you're going to put that data, supposedly in your code, supposedly you have some address over there. So this is 1, 2, 3, 4, 5, 6. So this is row number 1, oh sorry, row number 0, and this is row number 1. Another area, another way of doing it is that int table 2, 3, and here you write down 1, comma 2, brackets close, and then again 4. So the remaining empty spaces which you have not given, because here the it's 2, row are 2, which you have done, okay, but columns are 3. So here you have just given 1 and 2. Third is missing. So it will automatically put 0. So you can see the row 0 will be 120 and row number 2 will be 400. So if you have not given anything, the compiler will automatically give it 0. This is a two-dimensional array over there. And two-dimensional arrays are very good to store some data related to some class, supposedly. So supposedly in the rows, I have all the variables of all the students over there or their roll numbers over there, supposedly. And in the columns, I have their subjects and all that stuff marks over there. So it can be arranged inside a 2D array as well. But we'll come back to it later on. So remember, missing values are automatically initialized to 0. Now, how you're going to process this? This is something very important. Supposingly, you just want to print them. Okay, you just want to print them. The normal way of printing them is just simply previously you have been using a over here, and then you had a row over there. Here this was matrix, and then this was column over there. Here now you have row and column both, so this will be actually two nested for loops, and the outer loop will be row because you are going to process the row first, then the column. So this will be row number 0 first because it's going from 0 to 2, because you know this is 2. So this will go from 0 to 0 and 1, so it will be 2 rows. Here the column will be from 0, 1 and 2, so there will be 3 columns over there. So every time this matrix is going to be printed, or this line is going to be printed, is going to print 1, 2, and 3. And then afterwards, when this loop will be over, you will be having new line. So it will go on the next line, and then afterwards it will complete the program. So you just can print your whole, you can even print your 2D array in one line as well, but that will not be purpose. The purpose is that you want to print first row, or actually the row number 0 actually is in one line, and then the next row in the next line, and then the next row in the next line similarly. So this is the one way of processing the 2D arrays. So you just have to tell the row and column. Remember, if you are going to have a mismatch again, so that will be a problem and you will be having an issue over there. Now some examples, let's see some examples over there. We have a problem number 1, which is called as the average of an array. And very simply, you have a size again, you have a constant defined over there, a symbolic constant over here, which is 5, which is actually the size of that array. You have 10, 20, 30, 40, 50 over there. You have int sum is equal to 0. You can calculate the sum over there. So here inside this loop, what you are doing, you are having a variable sum and you are adding 10, 20, 30, 40, 50, and just adding up. Afterwards, you have another variable, because when you're going to divide it by 5 over there, because 5 is here the value of this symbolic constant size word over there, so this will be divided by 5. So you have to typecast it. This is called as typecasting, because you want your answer to be in floating point, or in more precision, so this is double over here. So here in printf you are doing the sum, so sum, and you are printing the variable sum, whatever that sum value came out to be. 10 plus 20 30, 30 plus 30 60, 60 plus 40 100, and 100 plus 50 150. So 150 will be printed over there, and the average will be 150 divided by 5, that will be 30.00, because this is point 0.2, so this will be 2 times after the decimal digit, that will be there. So this is one way of having your average of an array. Now this can go to 100 of that also, it can go to 200 values inside an array. Previously, whenever you wanted to have an average of two or three different numbers, you had to store them inside variables. Now you just need to have an array, and that array is controlling how you are actually saving that one. Then afterwards, you have a reversing an array over here, and that reversing an array over here, if you have an array over there, this is 1, 2, 3, 4, 5. Now reversing means, what does reversing mean? Reversing means that the 5 comes here, 1 goes over there, 4 comes over there. The middle one will remain the same because you are reversing it. So if this was 0 position, this was 1, this was 2, this was 3, this was 4. So you are actually going to swap the extreme ends. So how you're going to do that? Now see this one. This loop actually does the miracle over there, and how this is being done. See this thing. Now whenever you want to swap it, the middle one is not going to be swapped. Remember, if you are having an odd number of values inside your array, then the middle one is not going to be swapped. Remember, this is not going to be there. So you are going to divide 5 by 2. 5 by 2 means 2. So this means you have to do two swappings. One is for 1 and 2, other one 4 and 5. So 1 has to be swapped with 5, 4 has to be swapped with 2. 3 will remain the same because here the number of is odd. Now if it was supposedly even, let's say it was 1, 2, 3, 4, 5, 6, then size divided by 2 will be 3. So this outer loop will now go from 0 till 3. That will be 6 divided by 2, that will be 3. So 0, 1, 2. So there will be 0, 1, and 2. Supposedly there was a 6 also there. So what will happen? This loop will run for 3 times. Now when this is run 3 times, you have to take this element, swap it with the last element. Take the second element, swap it with the next element. So here, if I is equal to 0, what you are going to do, first of all, store this value of AR array into I, which is actually the number over there. So you're going to take this one value, store it inside a temporary variable for the time being, and inside this location, take this value and print it here, because of course you have to swap it. Again, this is a swapping. You are reversing the elements of an array, so you have to swap it. So when you are going to reverse it, this will be array I over here into array into size minus 1 minus I. Now what is size over here? In our case, in this case, this is 5. 5 minus 1 minus I at present is 0. So this will be 5 minus 1, 4 minus 0, 4. What is 4? 0, 1, 2, 3, 4. At 4, this is 5 value, and here this is 1. So 5 will be copied to 1. So here in this value, or in this location, which is array 0, this will be copied a 5 value. And now you need to change this value to the temporary value which we have stored previously, and that was stored inside this temp variable. So this thing copied on this side, because the destination is always on the left hand side. So the destination now is equal to temp. So you are now just swapping the values of extreme ends. So 1 is going to be swapped with 5, 2 is going to be swapped with 4, 3 will still remain the same because that is always at the middle position. This will only remain if it is an odd number. Remember, the odd number is there. So this is a reversing an array. This will be done, and this will continue to go on. And you, if you want to print it, you can just do the printing of the array, and this will be totally reversed. You can try this code, and it's completely flawless. It's going to work easily over there, and you can do it for like any number of array elements, supposedly 100, 150, or whatever. Next thing, very important, count the occurrences. Now here, this is something very important. Now here, supposingly, you want to find out inside this array how many times 5 has occurred. Here, 1, 2, 3, 4. 4 times it has occurred. So here what you are going to, it now this is not something like a search. It's not linear search. Here, this is count the occurrences. Supposingly, I just want to find it out, okay, in the exam, how many students have got 20 marks. Okay, or exactly 20. So for that purpose, if I have an array of all the marks of all the students over there, then I just need to go through this array and you have to count the occurrences. For this purpose, I have to run the array for 0 to whatever the position may be the last. That is actually size over here is 8. So this will be 7. And if that number which I am seeing over there is equal to the search value, and that search value in this case is 5 over here, then I'm going to get count plus plus. So very simply, it will count here. Okay, this value is equal to 5. Yes, count plus plus, count will be made 1. Then this value is going to be compared with this one. No, sorry. This value will be compared again. Yes, this one. So count will be made now 2. This one, no. This one, again, yes, over there. So this will count how many times that 5 is going to be there. This can go to like 1000 values inside an array or something like that. And here at the end, you can print f your statement over there. That is actually the search value and the count. So this one appears. So 5 appears over here, 1, 2, 3, 4 times. So very simple. This is actually just counting the occurrences over there, how this count is being occurring over there. Then next thing, very important, which is again very much easy, nothing fancy over there. This is actually finding the maximum and the minimum over there. You have two variables, one is minimum, one is maximum. You have an array over there. Now in this array, you want to find out the minimum or maximum. You just have to loop through the whole array. Now, first of all, you have to make your minimum and maximum variables equal to the starting element. Well and good, no issues. So you have made it equal to this one. Now, when you have done this one, first element over there. Now you are going to loop it through again 0, 1, 2, 3, 4, 5 because the size is 6. So it will go from 0, 1, 2, 3, 4, 5. And this if else statement will find out the minimum. So if array I is less than minimum, then minimum is equal to this one. So it's going to compare this value of 45 with the first element. If this is less than minimum, then it will go. No, it's not because it's exactly they both are the same. So it will not go inside this for loop. Then it goes for the maximum. If it is maximum, no, it will also not go. Then it will go for the second one. So now 23 will be compared with 45. Yes, 23 is less than this value. So now minimum will be 23. So this if else statement will be now going inside. It will be true when this second element or actually the index 1 will be over there. So this 23 will be compared with 45 and now the minimum value will change. So every time you are comparing the value, if that is the minimum than the previous one, then you are changing your minimum variable. So when after this whole loop is done, the minimum and maximum, they both are working totally separate from each other. So at the end, you can print your maximum and the minimum. So in your array, you want to find out, supposingly this is an array of all the marks of all the students. I want to find out, okay, where is the minimum value? Where is the maximum value? I can find it out very easily by using this one. But you just have to iterate through all the values of your array. So this is something very important. Then another example, sum of each array. If it's a 2D array, supposedly you have this one, you can see 1, 2, 3, you have 3 rows, and how many columns are there? There are 4. So here, this is rows equal to 3, columns equal to 4. This is a symbolic constant over there. You can see over there, and you have the 4 int rows equal to 0, and this is row less than rows over there. So this is the inner one. This one is the column for loop. So when you are going to add it, so you're just going to go through the first row. So and this will be row equal to 0. So this 1, 2, 3, 4 will be added and it's going to print. So sum of row first, which is actually over here, and that will be row number 0. The sum will be printed. And then afterwards, it will again go to up and sum will be again 0. So only the first row sum will be there, or actually row number 0 will be there, then row number 1 will be sum will be there, and then row number 3 sum will be there. So in this way, you can have your sum of all the values of a matrix in a row. You can do this for the column as well. You just have to tweak a little bit code. In fact, try this one. If you want to copy or multiply or maybe plus over there for each matrices over there, then you can actually do that very easily. So this is one very big problem. Now, one very important over there, I will just go through this one and I guess problem number 8 and all that, you can go it yourself over there. If you want to check it out, if an array is sorted or not. So if you have an array sorted over there, how you are going to find it out? Very simple. Compare one value with the next one. If the iteration again, so you loop through your array again from 0 to whatever the last position here. In this case, this is going to be 5, so this will be 4 over there. So this will be 5 minus 1, it will be 4 over here. So this will be 0, 1, 2, 3, 4 over there. So here this will go up till 40. So it will run for this one position, this position, this position, this position. And when it will run for 40, it will compare with the next value. So here you can see if array I is greater than the next value. So if it is this position, if I is equal to 0, the starting of this for loop, so this will be comparing 10 with 20. If this is there, it's not sorted. So if one of the value is not compliance, which means supposedly 20 was here, 10 was here. So this is not sorted. This is not in ascending order. So you can do it very easily by having this compared with this one. If this is going to be larger than this value, then this means this is not sorted. So you just can break the loop and you can out of this main function and you can just write it down. Okay, is sorted is equal to 0. So if this is there, so array is sorted, otherwise it's not sorted over there. So your is sorted is equal to 1, and if this is remains as 1, this means that all the elements are in ascending order. Now this is in sorted order. Now if you want to make it in descending order, you just need to change the expression over there. So this is going to be, if this is like 50 here, 40 here, 30 here, 20 here, 10 here, so this is a decrementing order of your array. So you can do that one also if it is asked to you. This is in ascending order. If it is asked a question how you are going to find it out in descending order, you can do that one as well. So this is over here. Kindly go through this frequency counter. This is something about that how many times value is being used over there. It's a very simple problem. Kindly go through this one. It's a very important thing. So you can go through this one. I just want to finish this off with some common mistakes which we do normally inside arrays over there. And most probably then I will make a small part when we are going to do coding over there. I just want to make this part a smaller one. So the first common mistakes is this, that you are having an array of 5 length over there, but you are also making the for loop run from 0 to up till 5. It should only remain to 4. So this equal to sign should not be there. This is very important. I have done this previously also. I've told you if you are going to do it, it will be a buffer overflow or the program will crash or undefined behavior or maybe some memory location else will be printed over there. So that's going to be wrong. So always, whenever you are talking about arrays over there, if you're starting from 0, because of course you have to start from 0 because the index starts from 0, then this equal to sign should not be there as shown over there. This is the correct code over there. Then a very common mistake is this, that you make arrays, you declare them, but you don't initialize them. So if you have an array just like this one and you just print it, it will be printing garbage. From the memory, it will be just taking out whatever that binary value and it's going to print in over there. So this is very important that you initialize them either to 0, at least 0, so that it's print 0, because this 0 means that all will be having 0 values or all 5 values will be 0, or compiler would automatically make all those 5 values equal to 0 over there. Then very important, I told you in the last lecture also that if you have a string and you are putting it inside in form of these characters, then the last character should be equal to a null terminator. That is actually this point when this tells it that this string is at the end over there. So this way, so if you are going to now print this name over there, like this is John, so it may print garbage over there. So this is going to be a very big problem over there. So always have, if you are marking it in form of characters, then please always do it. Or if you don't want this problem to be occur, then you can make it something like this: character name, and with no values inside it, just write down the string whole. It will automatically assign this 0, this is 1, this is 2, this is 3, this is 4. So this will be 5 automatically added. You don't need to write down the value of the length whenever you're writing down a string inside an array which is character data type. Remember this very importantly. If you are putting in characters by separated by commas, then you have to always put this null terminator or this \0 at the end. This is the common important point or normal done in the mistakes inside the strings over there. Then a very common mistake, you can't compare arrays. Remember, just like you have been comparing A with B or X with Y or something like that, you can only compare their values. You can compare one position with the other, but you can't make it. So if you have an array of A, you have an array of B, you can't make A equal to B and say, okay, this is printf and equal. No, that's wrong. That cannot be done. At least in C, you can't do it. So maybe in JavaScript or some other language you can do it over there, but again it comes with some limitations over there. But here in C language you can't do that one over there. So if you want to compare two arrays over there and they are of the same length over there, then the best way is run a for loop, compare each position with each position, and then if it is, then print it. Otherwise don't do it anything. So please never compare arrays. This is very important. Yes, arrays elements can be compared, but never compare in full array. So if this is an array A, array B, you can't compare it. Then a very common mistake which you normally have it, that is by whenever you are taking an input or string, because up till now you have been not been taking a input as a string or a character up till now. So here you have a variable which is name and it is having 10 positions inside it. Of course, the last position is going to be the null terminator. So this means you can only print 9. But here you have not specified with this format specifier that it will be 9 characters. So user could type 50 characters over there. So to avoid it, you have to write down 9s over there, and this will actually take strings and it will read maximum 9 characters plus one null terminator, because that's why it's 10. So it can take 9. So if this is not done, the buffer overflow can crash the program or create security, because now you are going inside some other memory location and your compiler may not be allowed by your Windows or your Mac OS operating system, because you are actually doing a C language code inside a compiler. So this is something very, very important. So always, whenever you are taking an input from the user, always write down this format specifier percentage s, not just percentage s, write down percentage, the value which you want your user to enter over there, because only that specific 9 or 8 or whatever will be taken from the keyboard. Even if you have entered like 50 characters over there, only the first 9 will be taken as an input over there. So there were very common 5 mistakes over there which you are normally done by students over there inside your arrays over there. Now I would like you to go through this exercise 1, exercise 2, exercise 3, and exercise 4, which is exactly the same we have done already over there, which you are rotating it by one position left or right over there, and then matrix addition, or you can do the matrix multiplication also. Hopefully I will do it in the class, or maybe inside a video I will do the matrix addition or the matrix multiplication. And remember that nowadays AI is going to be the most important factor, and for this matrix addition and matrix multiplication there are full CUDA codes or tensor cores available in AI processors which they can do it. Otherwise, if you are doing it on a normal PC which you are at present doing the C language coding, they are going to take a lot amount of time. So for to avoid it, AI processors, they have more cores, and those cores which are actually the CPU cores, they can do it in a very, very fast amount of time. That's why your AI or large language models, they have matrices. They have 3 cross 3 matrices, mostly, or 4 cross 4 matrices, and they are actually used over there. So this matrix addition, multiplication, conjugate, or inverse, they are very, very important codes, and I want you to practice this one on your C language, because when you have done it on C language, then if you are going to make a large language model for AI, then they are going to be much, much beneficial. So I will make a small part for this all exercises over there. And after this exercises, this is just the important reminders and the little differences over there. So nothing fancy in this part over there. So I will try to have this one. So today we have talked about in this part how 2D arrays are there. I have talked about some of these problems over there. I have showed you the bubble sort algorithm or the linear search algorithm over there. I hope this was beneficial for you. Thank you.